this into two separate parts. So here's the second part, because this gets a little bit trickier. So now we're going to start adding, subtracting rational expressions, which basically means we're going to start to see some variables and some variable expressions show up in our problems, which makes it a little bit trickier. So again, top of page 9 in your notes, go ahead and add these 6 steps. First, we're going to factor the denominators. Step 2, we're going to collect one of each factor. Step 3, anything that a fraction was missing is multiplied on the top and the bottom. Multiply the fractions, add the numerators, maybe leave them as factors, maybe combine like terms. We'll just kind of wait and see on each problem, and then leave the denominator in factored form. So this actually looks very, very similar to example 2 from the first video, but this time we're going to have some variables show up in our problems. So here's our first example, example 3a. I need to first go through and factor anything that I can. So it looks like this can be factored to 3x minus 2 with a GCF. I don't see anything to be factored there, and I don't see anything to be factored there. Now, I'm going to rewrite each little piece and then leave a space to add anything that it's missing. Actually, I'm going to go ahead and change x squared to be x times x. So just like we did with the fraction, let's go through and find any pieces. There's an x. In this second one here, this guy's missing an x, so he needs an x, and then this one has an x. Next thing I see, here's 3x minus 2. That one has a 3x minus 2. This does not have a 3x minus 2. Let's keep going. We're out of factors in the first one. We're actually out of factors in the second one. But here's an x. This guy needs an x. And then the middle one also needs an x. Okay, so now if we look through each denominator, I see there's an x, a 3x minus 2, and an x. I see a 3x minus 2, an x, and an x. I see an x, and a 3x minus 2. So everyone has the exact same denominators. So now I need to simplify my numerators a little bit. So in this first one, this becomes 6x. I'm going to go ahead and leave it over x squared times 3x minus 2. This one, in the middle, I've got 5 times x, so that is 5x squared over x squared times 3x minus 2. And then on the last one, we've got to be really careful because this ends up, we have to distribute this negative 2 to everyone. So I'm actually going to make this one big fraction. I'm sorry. Let's change this a little bit. We've got a 6x here plus 5x squared here. And then this becomes a minus 6x when you distribute plus 4. So let's not do that. That's just sort of how we got there. But let's write it this way instead. Okay, because what you're going to see now is in this numerator, we've got a 6x minus 6x. So those simplify to be 0. And now let's look at what's left over. And there's our answer. Now we do need to check the numerators to see if by chance anything can factor out of that one, but in this case it does not. Next example, we're going to do the exact same thing. So 2x plus 5 on the top. I'm going to factor x plus 3 times x plus 3. This is difference of squares, x plus 3 times x minus 3. And then this last piece cannot be factored. Okay, now let's figure out what everyone has and what everyone gets. So there's a space for what it needs. There's a space for what it needs. And there's a space for what it needs. All right, let's go through and check our factors. First, I see an x plus 3 here. I see an x plus 3 there. I do not see an x plus 3. So it needs x plus 3 top and bottom. I see another x plus 3. So it needs an x plus 3. It needs an x plus 3. And then there's our x plus 3 there. Nothing left in the first fraction. This middle one has an x minus 3, so that means this guy needs an x minus 3. We already have an x minus 3 there. We have an x minus 3. So now it looks like our denominators are all the same. Okay, now this one, I'm going to kind of save myself a little bit of space. I'm just going to worry about the numerator for just a second, because there's a lot of stuff going on in this numerator. So again, this kind of goes back to what we did before in section 1.3. This is where we have to be really good at multiplying binomials. So I'm going to FOIL here and get 2x squared minus 6x plus 5x minus 15. I'm going to distribute and get x squared. Hold on a second. I'm going to 3x. And then over here, so 1 times x plus 3 times x plus 3. Obviously, anything times 1 is not really going to do anything. So I just need to FOIL this one and get x squared plus 3x plus 9. All right, I'm going to go through and combine my like terms, and actually that'll be my answer. So my numerator now is all those different factors. And then on the top, we're just going to go through and kind of collect all of the similar factors. So I've got 2x squared plus another one, that's 3, plus another one, that's 4. So 4x squared. Now let's go through and collect our x's. I've got negative 6 plus 5, so right now I'm at negative 1. Plus 3, I'm at positive 2. Plus 3, I'm at 5. Plus 3 more, now I'm at 8. And then my constants, negative 15 plus 9. That's going to give me negative 6. Now, one thing I would like you guys to see real quick is that 2 is kind of a GCF that just showed up in the numerator. If you can factor that out, that's going to make it a little bit cleaner and a little bit nicer in general. So let's go ahead and do that. But then nothing else can be factored. So there's our answer to that one. I'm going to go ahead and have you write down some steps for examples 4 and 5, and then we'll have a separate video for those 2 examples. So for example 4, simplifying a complex fraction, the steps that I'd like you to write down is to simplify the numerator. So using what we've just done in example 3, simplify the numerator. Step 2, you're going to simplify the denominator, just like we did in example 3. And then remember, division really just means multiply by the reciprocal. So that's what you're going to do. And this is really just 2 problems like example 3, just put into 1. So like I said, I'll come back and do this example. And then at the very bottom of page 9, rationalizing denominators using conjugates. These are almost like trick questions. They're kind of set up to be actually much, much easier than you think. So the conjugate is just the same math stuff, but a different sign. And what we're going to do is multiply the top and the bottom by that conjugate. The denominator will always be a special product. We're trying to get rid of our radicals in the bottom, so it's going to end up with a special product. And then you just have to multiply the numerator like we've done before. So go ahead and write down those notes. If you want to watch the videos for those 2 examples, I'll post that separately, but you don't have to. So this is the end of section 1.4. Fractional expressions, and then this is actually the end of chapter 1 also. So great job, guys.